Figure 5 shows one molecule of each of four different substances, A, B, C, and D. These are all simple molecules. So we have methane, sulfur dioxide, water, and carbon dioxide. State the formula of molecule of substance B. So this would be CH4, this would be H2O, this would be CO2, so this would be SO2, sulfur dioxide. As a general rule, oxygen never comes first in the compound, so you'd never do OH2, it would be H2O, this would be SO2, CO2, oxygen is never written first. Substance C can be formed by burning an element in oxygen. Write the word equation for this reaction. It's really important you write a word equation and not a chemical equation, otherwise you won't get the mark. So it can be formed by burning an element in oxygen. Write the word equation. So this is easier than it looks. Basically, we know that this is made by hydrogen reacting with oxygen. So what do we burn in oxygen? It must be hydrogen. So the word equation would be hydrogen plus oxygen produces water. Hydrogen plus oxygen, water. Consider the substances A, B, and D. A, B, and D. Give the letters of the two substances that can be formed by burning an element in oxygen. So this is quite easy. If it's burnt in oxygen, you'd expect oxygen to be in the compound. This one doesn't have oxygen, these two do. So B and D would be the answers. The amount of oxygen in the atmosphere has increased since the Earth's early atmosphere was formed. Explain what has caused this change. So basically, plants or algae, green plants evolved which could photosynthesize. They took in carbon dioxide and released oxygen. It says explain what caused this change. So you'd have to say what happened and what was the effect of this. So what happened was plants evolved, and the effect of this was they carried out photosynthesis. Remember, it's for 2 marks, so look for 2 marking points. Carbon dioxide is present in the Earth's atmosphere. Some processes increase the amount of carbon dioxide in the atmosphere, other processes decrease it. Draw one straight line from each change in the amount of carbon dioxide in the atmosphere to the process causing the change. So make sure you read what says one straight line from each change, so not lots of lines, to the process causing the change. So what is causing an increase in the amount of carbon dioxide? Carbon dioxide absorbing the sun's energy, that's irrelevant. Carbon dioxide dissolving the oceans, that would decrease it. Volcanic emissions, yes. Using argon lights, irrelevant. Burning hydrogen, irrelevant. Not to do argon and hydrogen have nothing to do with carbon and oxygen, carbon dioxide. So increase would be this one here, volcanic emissions, and decrease carbon dioxide dissolving in the oceans. Figure 6 shows a graph of the amount of carbon dioxide in the Earth's atmosphere from 1985 to 2005. So you can see this fluctuating graph pattern, but it is steadily going up. So there's an overall increase, even though we're going up and down, but overall trend is it's increasing. Describe how the amount of carbon dioxide in the Earth's atmosphere varies within each year. So this is tricky because you're actually just looking at a single year. So you know this is 1985 to 6, 7, 8. So this 2 squares here is 1 year. So you can see that levels of carbon dioxide go up, they increase to a peak and then go down. So don't overthink describing a pattern, just say what you see. It increases, then decreases, 1 mark. It's only 1 mark. Then it's just says describe the overall trend in the amount of carbon dioxide in the Earth's atmosphere from 1985 to 2005. So now we're going right across the graph, 85 to 2005. The overall trend, again 1 mark, is that the level is increasing. You can see that if you were to draw a straight line through this, it would be an increase, a very strong positive increase. So it increases, done. Don't overthink it, just go for what you see. Calculate the change in the amount of carbon dioxide in the Earth's atmosphere from the beginning of 1990 to the beginning of 2000. The change in the amount. So this is a little bit more involved. We have to look at 1990 and 2000. So 1990 and 2000 is this region from here to here. So we have to go up the graph and see where it meets the line at 1990, and then go up the graph and see where it meets at 2000. And if we did that, we'd have to read off the graph. So if we brought these lines here, we'd see that the change it's talking about is between 350 and this value here. Now, there's a gap of 10 here, 60 and 70, and there's 10 squares. So each square is equal to 1. So we simply add here, so we got a gap of 10 here, 10, 11, 12, 13, 14, 15. So we have a change in 15 parts per million, as is states in the units on the y-axis.